Find the equation of the line in point slope and slope intercept form, that is the perpendicular bisector of the segment that connects these 2 points. So because of the word bisector, we need to find the midpoint of these 2 coordinate points. To find the midpoint, we add the x's, which I'll go ahead and show, and divide by 2, and add the y's, and divide by 2, and tidy that up, and that'll get us our midpoint. The midpoint is crucial because the line segment is a bisector. So I see 2 and -4 is our midpoint. Next we're going to find is the slope of this line that connects these 2 points. So difference of the y's over difference of the x's is what I'm about to do. I'll choose this y and I'll subtract the second y. Over the x's, which gives me -4 over -10. And I always recommend simplifying that. To work with a simplified slope is a lot better than something that might be ugly. This is going to be positive 2/5. So that's the slope of the line that connects our line segment. Now because of the word perpendicular, we need to take the opposite reciprocal or negative reciprocal of the slope we just found. Our formula for point slope, if we remember, is y minus y1 equals the slope times x minus x1. x1 and y1 is our midpoint, so bringing those over, y minus -4 becomes y plus 4. The slope that we use, because of the word perpendicular, is the opposite reciprocal of this 2/5. So opposite would make it negative, reciprocal 5/2. The x value of our midpoint was this 2, and that concludes point slope form, which I'll box. The bold and tells me to put that in slope intercept form, so at this point I am going to distribute to get rid of the parentheses and then bring the 4 over, and we'll have slope intercept form. So first distribute, and then bring the 4 over, and you got it. Plus 1. Box both answers since it's asking for both. And that concludes point slope. Okay, I'm going to put up problem number 2. When I do so, I've used the same directions, so you're just getting 2 new coordinate points. So right now you need to pause your video so that you can copy this problem and do it to the best of your ability, and I'll throw the answer up here in a second. Alright, press pause. Okay, welcome back. I hope that went well. Let's take a look at the solution to problem number 2 and see if that's what you got. Okay, let's attempt problem number 3. If you need more time, press pause. Join me for 3. Okay. Here is problem number 3. Same directions, perpendicular bisector, 2 different coordinate points. You'll notice I put no decimals, so we're going to keep everything with fractions. I do not care if they are improper fractions. Alright, you should have pressed pause. Working on the problem now, press pause. And welcome back. Okay. here's the solution to problem number 3. And here's an example of where you might want to take that slope that was fairly ugly, tidied up, simplify it, so that you work with a much more friendly slope in the equation. But there are the two solutions, point slope and slope intercept form.